Assalamu alaikum students. After a gap, I'm here with the video on the connected particles. Okay, so let's start this. Before this chapter, we have studied about finding the acceleration, the tension in the string, and all other things which were about just one object. Okay, so just to have a recap, let me tell you, for example, we started by saying that, for example, there is a particle, there is an object, it has some weight, okay, and then there is the r over here, and then if there is an inclined force, okay, let's say this is t, and then there is a frictional force, okay, and then you were resolving this t parallel to this direction and perpendicular to this direction. Okay, so this was your t cos theta and this was your t sin theta. You have also seen the situations where we had the objects moving on the inclined planes. Okay, for example, here is an object, this is in contact with the surface, here is the weight, and then you were resolving this weight parallel and perpendicular to this inclined surface, and obviously you knew this angle over here, and then like you know how to deal with this situation, and then you were given a force over here. Sometimes there was a force like this. So anyhow, before this we have studied the forces, the impact of the forces acting on just one particle. Okay, now we shall study about two or more particles which are connected through an inelastic string or a rope or whatever. Okay, so let me start now. For example, we have there is a rope over here, and here is a person A holding it from this, and here is a person B holding this, and suppose there is a tug of war between these two people, A and B. They are trying to pull each other towards their side. Okay, so as you have done that Newton's third law, that every action has an equal and opposite reaction. Now if if you just focus on this rope, so if this B pulls A with the tension T, okay, B is pulling, A is pulling, and there is an overall tension in the string. Okay, so if the tension in the string is has to be shown over here, so we can show it two ways. Okay, so here is this T, this is T. At this moment we have shown the tensions outwards. This is called the thrust situation. Okay, and then we can also show this tension, like this is your A, this is your B, and we can show this inwards as well. Okay, so this is the T over here, this is the T over here. Okay, if you focus on this particle A, like in both of these cases, if you focus on this particle A, so the tension in the string or this rope is going to be this. Okay, because there is an impact on A towards the direction of B. Okay, so here this is the tension and this is the tension which is basically acting on A. Okay, and similarly if you look consider this B over here, so this is the tension in the rope over here, and this one over here which is acting on B, and on the whole on this rope throughout the tension is same and it is in opposite directions. Okay, now suppose we have a situation where this rope has gone over a pulley. Okay, and here is this A now and here is this B now. Okay, so this is the same rope. Okay, so this A will have an upward thrust over here. Okay, so that is because this B is not allowing this A to fall freely downwards. Okay, because A definitely has got a weight, okay? So its weight would try this A to go down towards the ground, okay? And similarly, this B, it cannot fall freely because it is connected to this A through this rope, okay? So here is this tension. So this tension this is the same thing as we have in these diagrams, okay? So the weights, they are trying these particles to go down, but the tension, the string, this is holding them up, okay? Now you can have the same rope, maybe in this case, for example, here is this is the particle A over here, the string going like this, and here is a particle B, okay? So this A has the tension in the rope towards this pulley, because of the weight of this particle B, it wants this B to go down, but again this B cannot fall freely downwards because of the tension in the string, okay? So this would be like this, okay? And if I can show you in another case, for example, here is the pulley is over here, and this particle is A over here, and here is the particle B. So this is your B over here. So again, this is the tension, and this one is the tension over here, okay? So this is the basic thing, that when two particles, they are connected together, so the string or the rope that is connecting them, that will have throughout the same tension, okay? But you will determine the direction of the tension by focusing on that particular point or the object, okay? So for example, if you look at this A, then the tension is like, this is the tension which is acting on A, and for this B, this is the tension. So this all starts from this horizontal situation like this, and we can even show this in a vertical situation. Like for example, suppose there is this there is a ceiling, there is a string, and there is a particle A, okay? Now suppose the mass of the particle A is 2 kg, okay? Now its weight is downwards, that is 20 newtons. So here is the tension. So right now this A is in equilibrium. So this upward tension, that is equal to the downward weight, okay? So the tension right now, that is equal to 20 newtons, okay? Now suppose there is another string attached to this particle B, and then there is another, so particle A, and then there is another particle B over here, okay? And let's say this B also has a mass of 2 kg, okay? Now I shall call this as T1, and I shall be calling this as T2, and its weight is 20 newtons, okay? So now we have to determine the tension in these two different strings, okay? So if you just use the common sense, then this T1 would actually be the equal to the weight of these two particles. T1 should be 40 Newton, and then T2 should be 20 Newton, okay? But the thing is, here in this string, there are two particles over here, okay? So if you look at the particle B, then the tension in this string is, this T2 is upward. But the same string is connected with the particle A as well, okay? So you will be showing this same tension here as well, okay? So if we look at the particle A right now, for the particle A, let me write this, this T1 is equal to 20 plus T2, because if you just look at this point over here, there is the tension upward, that is T1, and on this string which is connecting A and B, there is the tension T2. So by looking at this A, the tension T2 is like, this has to be downwards, okay? And then its weight, which is 20 Newton. So there are actually three forces acting on this particle A. One is this tension upwards, T1, the tension T2, and thirdly, it's the weight of the particle A, okay? And now if you look at this particle B now, the particle B, it has two vertical forces acting on it. One is this upward tension T2, which is holding this particle, not allowing this to go down, okay, and the second is its weight, okay. So this gives us this T2 that is equal to 20 newtons. This T2, because this is this a state of equilibrium, so this T2 is equal to this downward 20, okay. So if you put this T2 into this equation over here, you will get that T1 equal to 40 newton. That was what I was saying, that using the common sense you can say that this T1 is going to be 40 newtons, okay. So later maybe in the next video, if I'll be explaining that you can consider this as one block over here, okay, this T2 cancelling this T2, and like, you know, the total weight over here is going to be 40, so you can directly say that this T1 is equal to 40, okay. So I have just like, you know, told you one thing over here, that in a same string, throughout that string you have the same tensions but in opposite directions, okay. So do ask me if there is any problem, okay. So I'm moving towards the second video now, where I'll be solving some examples, some problems, and we shall be using the Newton's second law. This is basically we derived this from the third law of Uncle Newton, where, like, you know, we have the two forces opposite and they are equal as well, okay. And the second law is our favorite law, that is F equal to ma thing, okay. So that's it from this video, and I'm just going to record the second video where I'll be showing some solutions of the problems related to the connected particles. Thank you. Allah Hafiz.